Hello, I'm António Rui de Silva, and I'm going to present the work done together with Nuno Gonçalves, Diogo Faustino, and Manuel Portela on the Monolith Modularization towards Microservices Refactoring and Performance Trade-offs. Well, the context is we are migrating Monolith to a microservice architecture, and we want to study this migration in terms of the refactorings and performance. And the idea is that we start from a monolith and we go through a modular monolith to finally migrate the complete system to a microservice architecture. And we look at the related work, we realize the migration from monolith to microservice architecture. There is no discussion of the redesign effort and impact on the functionality. On the other hand, the performance comparison between monolith and microservice architecture, we see a lot of variations in terms of the architectural styles, in terms of, for instance, if you use sagas or event sourcing, and variations on the technology, whether you use a bare metal or virtual machines. So it's very difficult to compare and to conclude about what is really the impact in terms of performance. So, because there are so many variables, we define the strategy of this research. And the strategy is to analyze the migration of a monolith to a modular monolith in terms of the refactorings and performance. So by analyzing these in this intermediate step, basically we isolate several variables and will be relevant at the end in the final migration, but we want to see if just in the first step what is the impact of the migration. So we need to define what is a modular monolith, and basically we define modules, and we define two types of interactions between modules. Uses interactions, which define dependent relationships between modules, and notification interactions, where there are relationships between modules that do not define any dependence. And the reason because we distinguish these two types of interactions is to avoid to have circular dependencies between modules. We have migrated a Spring Boot application, the digital archive of the Book of Disquiet, and which is a Java Spring Boot application with 152 controllers, 55 domain entities, and around 30,000 lines of code. As you see here, just a partial view of the domain model. What we start from in the monolith is an object-oriented domain model of persistent entities with several interrelationships between them. Okay. And when we identify the modules, we identify basically two situations. So domain entities that belong to a single module, which are in the non-gray color, and domain entities that belong to several domain modules. So what was the refactorings we have done? The first refactoring was basically these domain entities that belong to the different domain modules and actually interact with the domain entities in these modules through associations, and we call them God classes. And what we have done here is to split the class into several smaller classes when each one of these parts belong to a single module. Then another situation is again with the domain entities that belong to several modules, but now it's through inheritance relationships. Okay, and what the refactoring we applied here was a remove superclass. That basically we move the information, the methods, and the data from the superclasses to subclasses that belong to a single module. Finally, after applying these refactorings, you get domain entities that belong to different modules, and the only relationship that exists between them are associations. Actually, this proved to be basically the most important refactoring, and the one that has more impact in terms of, as we'll see, performance. And this is so you apply here the refactoring that is remove association. Finally, when you remove associations, we need to add data transfer objects, because now the information that goes through between these two domain modules need to be sent into using data transfer objects. And this is, so one domain model uses another domain model, and the other domain model notifies, so to have this one unidirectional dependence between them. So to do the evaluation, what we measure the number of modified entities in terms of the total domain entities of each one of the modules, and we realized that it was around 50%. You see here some modules that have that do not have any impact, but basically are modules that are usually modules that only read data, and they don't have their own domain entities. But you can see, not only in terms of the modified entities, but the number of data transfer objects that were defined, and the modified relationships and the removed relationships. It was a significant impact on the code that has to be changed. When we look at performance, after we have done the refactorings, the performance, and because we introduced these data transfer objects, the performance was not acceptable. So while we have done the refactorings, we have done a couple of optimizations. So these optimizations, the first one was to associate a database access index to the unique identifiers of domain entities exported to other modules. This is because there was a lot of interactions between modules when one module requires a domain information about a domain entity in another module using its unique identifier. Another optimization is whenever a data transfer object is generated, by default it is loaded with the values of all its attributes to reduce further intermodule invocations. And in a few cases it was necessary to have larger DTO objects which contained information associated with several interrelated domain entities. To evaluate the performance, what we have done, we pick 4 different functionalities that differ in the number of modules involved, the number of domain entities assessed, if they are data intensive and computational intensive. And so these different functionalities cover these different situations. Then we have done a performance analysis using JMeter, where we compare the performance in the monolith and in the modular monolith for 2 situations, when we have 100 fragments and 720 fragments. And we'll see that for most of the functionalities, there's a huge impact related with the transfer of information between modules. As you see in the source listing, we see here that it goes for 48% increase in the performance when you have 100 fragments, but then 555% when you have 720 fragments. But at the same time, we realize that in some cases the performance improved a little bit, and this is associated with some of the optimizations. And for data-intensive systems, since we used cache already in the monolith, we realized that when we increase the number of the fragments, we don't have a big variation in the performance. So the conclusion, the migration of a monolith to a modular monolith requires a significant amount of changes in the code. The data transfer objects significantly impact on the performance. The impact on performance varies with the characteristics of the functionality, and impact on latency is correlated with the impact on throughput. Okay, thank you.